now less than 15 minutes away from flight. I'm going to wait for the fuel overlay to come up again at some point. As we get under 15 minutes, or we are under 15 minutes here, let's talk a little bit about what's going to happen, because a lot of stuff's going to happen fast.
Yeah, so some of you might be able to see that little blurb that just popped up in the bottom right, but right now we are starting our stage 1 engine chill.
Right.
So we're pulling LOX through our Reaver LOX pumps, and that's in order to kind of chill them down and make sure that just like last time, we're not surprising them with any comparatively super cold fluid.
Temperature changes from ambient to super cold.
Yeah, exactly. So we're making sure those are ready for operation. We're starting kind of TTEB checkouts, TTEB being Apple. We're also looking for spin start verifications. We're looking for the fan favorite is the TVC wiggles.
TVC wiggles?
Yeah.
I think chat saw some TVC wiggles last time that I didn't see. So folks, we're going to try to get that camera up here in just a second. If you see the TVC wiggles happen, let us know in the chat, because it's there's a lot of stuff for us to keep an eye on here. But help us out if you see the TVC wiggles happening. Let us know. Apparently, chat went crazy last time.
Yeah, I didn't see any, but they saw some. I missed it. But yeah, the TVC wiggles are really fun. They should be starting at T-minus 13 minutes. So coming up pretty soon here, you should start to see those Reavers kind of wiggle around.
I just want to stare at the engines, but we got other stuff to talk about.
Me too. So yeah, I'll move down the list. A lot of this might seem a little repetitive. There's only so many ways to skin a cat.
That's okay.
But yeah, at T-minus 8 minutes, we'll start fuel pre-press. At T-minus 7 minutes, we'll do stage 2 TVC wiggles.
Right.
And we do have a camera in there, just like last time, so you might catch those too. At T-minus 6 minutes, Alpha will transition to internal power.
Okay.
So right now, it's plugged into ground side power. But we will need to disconnect that when we leave the ground. So we do it at T-minus 6 minutes, kind of to give Alpha a little bit of time to get it under its own power and make sure that everything's healthy.
Right.
This whole time, we're executing over 300, commands and health checks, most of them automated, if not all of them automated. So yeah, we'll disconnect Alpha from ground side power, and then it's kind of on its own in terms of that.
That's sort of like, all right, Rocket, you need to be able to operate without being connected to the ground, without being connected to power. So you don't do it right when liftoff occurs. You wanted to give it some chance to be on its own, but you want to provide it that support right up until, I guess, T-minus 6 minutes.
Yeah, we might be kicking it out of the house or off the planet even. Get off my planet.
Get off my planet. Nice.
But yeah, we want to make sure it's healthy before we send it.
Yep.
So at T-minus 5 minutes and 45 seconds, actually, you'll see those collar arms begin to open.
Right.
Those collar arms are kind of like a little necklace around Alpha's kind of lower stage 2 LOX tank. And what that does is it kind of supports the rocket at the kind of, oh, okay, yeah, they're open.
It looks like you can see them there. You can see them open right there below the frost line, sort of sticking out to the side like crab pinchers. I mean, right?
I will never be able to unsee that. Thank you.
Sorry.
But yeah, those collar arms open because we're about to send the rocket, and pretty soon here, that entire strong back will actually start to retract, and that's so that it's kind of out of the way for the rocket to lift off. I don't know if we've got a camera on them. Oh yeah, there's one.
We have cameras, Morgan.
We do have. I know you have cameras.
We have cameras.
We got cameras with cameras.
I like it.
But yeah, that strong back will pull back, and just all of that extra support we're giving Alpha, it won't be needed when it's time to send it. So we kind of cleared out of the way.
All right. What did we say last time? The non-required loading?
Yes. I knew you wouldn't let that one go.
I like it too much. I like hanging out with the engineers here, but it was the wind was it wasn't wind. It was non-required loading.
It's non-required loading. If we don't need to load Alpha, then why should we?
There you go. And a couple things will happen after that. We're still watching for that strong back to retract that's actually going to pull some of those umbilicals a little tight, not pulling them all the way off now, but they'll see them sort of stretch out there on the screen. And after that, I think we get into arming the FTS, right? Yeah.
So after you see those umbilicals pull tight and their QDs are kind of getting ready to separate, we'll arm the FTS at T-minus 4 minutes. The FTS is the flight termination system. It's kind of a normal safety thing that's required on all rockets.
Gotcha. Makes sense. Then we'll see some bleeds, get some air out of the line, that sort of stuff.
Yeah.
But that's what's coming up.
Yeah, that's what's coming up.
All right. And then, folks, we are rapidly approaching T-minus 10 minutes here. And what we are going to see after liftoff is going to happen really quickly as well. So, Morgan, let's talk through that really quickly, too.
Yeah. So we call our T0 not when we light our engines, but when we actually release the clamps that are holding Alpha to the pad,
Right.
and we let it go. So we'll actually light our 4 reavers at T-2 seconds. We'll have our stage 1 ignition, and then at T-0, we will open up the clamps, and Alpha will start to lift off.
Gotcha. And that's when T0 happens.
Yeah, that is T0. And then we'll be burning those stage 1 engines for 2+ minutes,
Right.
but at T+54 seconds, we'll actually hit Mach 1, so we'll go supersonic. And then at T+1 minute and 5 seconds, we will hit something called Max Q.
Max Q.
Max Q.
Well, you know something? We never talked about what the Q stands for. It's
Maximum
just a shortcut.
aerodynamic pressure. Yeah,
There's no Q in that.
There's no Q in that, but you know what? Engineers and mathematicians love to throw letters in our calculations because math wasn't hard enough.
So we talked a little bit about that last time, but
Yeah.
as a structures person, Max Q is definitely an important part of the flight for you.
Yes, completely unbiased answer from your local structures engineer. Max Q is the point where the vehicle experiences the most kind of loading and stress and strain, whatever you want to call it, that it will experience at any point during flight, because you're getting this crossover. You can probably Google a very nerdy graph if you want to.
You have to say nerdy graph.
I have to say nerdy graph. It's a crossover point between static and dynamic pressure. And at least for a rocket, it's different between rockets and airplanes. This happens when we're accelerating faster and faster out of the atmosphere, but that atmosphere is getting thinner and thinner.
Gotcha. We mentioned it last time, like you think, oh, well, the maximum pressure is just when it's going the fastest, right? When it has the highest speed or whatever. But it doesn't really work that way, because remember, the rocket is getting out of the atmosphere. And as it raises up out of the atmosphere gets thinner, so there's less aerodynamic forces acting on the rocket. So it is that sort of point where I almost feel like we need to show this on the next live stream.
Yeah, we really should.
Max Q graph.
We should grab a Max Q graph.
Nice. Anyways, folks, we are continuing to tick down here. Max Q, an important part. You'll be wiping.
That is the part where you will probably hear me like, whew, when it's actually going, because that's the part where my structures have done their job.
Right.
So we size them to be able to handle Max Q, but we can't size them to handle much more than that, because then it'd be super heavy.
Gotcha. All right. And then after that, you're going to see some perfectly normal things. Stage separation will occur. We'll see a stage 2 ignition when that lightning fires up and starts pushing the second stage the rest of the way into orbit. Fairing jettison. Totally normal thing as well. Don't need to be carrying the fairing along with you anymore. Yeah,
it's just extra mass. It's done its job protecting the payload from the PPF to the pad, and then from the pad to space using the ECS.
All right.
Sorry, that was a lot of acronyms back to back to back.
Did we say how that's? Wait, we said ECS and PPF, Payload Processing Facility, and ECS is Environmental
Control System.
Control Systems.
Yeah,
nice.
There we go.
We've done this a few times.
We've practiced a couple times.
All right, and that's going to continue going on for till T+8 minutes and 10 seconds when that second engine cuts off. And then we're going to have a long coast phase. And that is going to go all the way up until 44 minutes and 33 seconds when the first payloads will be deployed. That actually is going to take over 10 minutes, almost 11 minutes, just over 11 minutes for all the payloads to come out. Now, real quick, we know these payloads come off because we have telemetry coming down from the rocket. But in order to get that telemetry down, we need to send it somewhere. It needs to end up on the ground somehow, and that's where a ground station comes in. A little bit earlier, I heard on the sort of chatter that there might have been an issue with one of the ground stations, so some of the telemetry might not be coming down, but it wasn't a blocker for launch. So just because that one ground station wasn't there might not stop us from launching, but we may have a couple dropouts in the telemetry. Is that right?
Yeah, so if you don't have line of sight to a ground station, and this is including when you're kind of over the horizon of the Earth, over the curvature of the surface, you can't transmit your data until you have that line of sight. But like you said, we've been having an issue with one of our ground stations today, so basically what happens is we have to wait until we pass over the next one.
Gotcha. But there's multiple ground stations. It's not like just there's one location that you pass over and all the data comes down.
Yeah.
As the rocket goes around the globe, there's a couple different ground stations it can downlink to. So we'll see which one of those ground stations gets our telemetry and our updates there.
Yeah.
All right. We are going to stay live throughout most of that time and continue to share updates and other information about Firefly with you. We're going to talk a little bit about the NASA payloads that are on this mission, where they came from, where they go, hey, there goes the Strongback, it looks like.
I was going to say, don't you dare say Cotton Eye Joe.
I wasn't going to, but then you did. So,
man, I walked right into that
one.
one.
Right, you set yourself up. You played yourself. And then we're also going to talk a little bit about Firefly's upcoming mission to the moon, Blue Ghost. But I want to get one more question from the audience in here. I've got a couple more minutes. So this was a good one. Some very keen eyes out there. Why is Alpha's fairing and upper portion painted white? Last time it was silver and black. This time it's actually all nice and clean looking white.
Yeah, good eyes. Yeah, so we found through previous flight data that we were losing a little bit of propellant mass on stage 2 during its coast phase. Specifically, our cryo propellant, our cryo LOX was boiling off. Yeah, so we were losing the capability of that propellant to kind of take us further.
You're losing the propellant.
Exactly, yeah.
Right.
So what we figured was, by looking through data, we found that out, and then we decided in order to further optimize stage 2 and reclaim that propellant, we painted the thing white. Like, I'm sure, you know...
That's the thing.
When you wear a black shirt outside, you get hotter. When you wear a white shirt, you're less hot.
You're a little bit cooler.
Yeah, the color white just kind of bounces those wavelengths from the sun right off, so they never transform into heat, and they don't heat up your shirt. In this case, they don't heat up our rocket skin.
The rocket skin. Now, that explains the tankage, like why the second stage that actually holds the propellant, the LOX specifically there, is white. But why is the fairing white?
We thought it would look a little goofy if it went white, silver, white, black. So we thought it would look a lot cleaner if we just painted everything white. And, hey, maybe we'll, you know, bounce off some more light wavelengths just for funsies.
So there you have it, some thermal management with the white on the second stage and some fashion for the white on the... It would look super clean.
She had a bit of a makeover. She looks good. She's looking her best.
It really does look clean. Hey, shout out to the Next Spaceflight Discord for putting that question in my inbox. There's some super fans over there that really show up for the Firefly launches.
Yeah, I'm surprised somebody caught that. The color change.
It looks too good. It looks good.
It does look a little too good.
Yeah. All right, folks. The clock continues to tick. You can see the rocket. Look how alive the rocket looks. But we are coming up on T-minus 3 minutes. There's going to be a launch conductor no-go poll. We got another poll coming up here. You're going to hear the launch conductor hear or ask the chief engineer, the launch director, and the range operations commander for their final goes and commits to launch. Now, I don't want to talk over them because this sort of final go for launch.
Yeah.
So let's go ahead and listen in on the launch net.
Ten seconds to final cryohelium press.
T-minus 2 minutes. This is the final commit for launch. Chief Engineer.
C is go. Send it.
Launch Director.
Go.
Rock.
Rock, range green.
We are go for launch.
And there you heard it, folks. They are go for launch. Less than 2 minutes now for Flight 5. There's all the Fireflies watching nearby here in Austin, ready for this to go. There you go.
Yeah, yes.
Well, let's go ahead and listen in on the sounds of the pad and the control room, and we will see you on the other side.
Helium QD's venting shortly.
Use pole arms.
T-minus 60 seconds.
They are in work.
T-minus 30 seconds. Alpha transitions to autonomous mode.
Alarms off.
Normal stage 1 TVC motion.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. Operator transition to ground. That's it.
I have fire at the MLS.
You're good.
Can't confirm. I see no fires in the fluid.
Vehicle
filters.
supersonic.
They're on the MLS.
Max Q.
You can really see those exhaust gases expanding there.
Yeah, as we get into thinner and thinner atmosphere.
Yep.
It's beautiful.
Visual confirmation of the thinning atmosphere as it pulls away from the planet.
MLS fire appears to be out. I see no other fires on the pad.
Look at that.
Stage
Nico.
separation.
Stage 2 ignition. Chamber pressure looks nominal.
They're the fairings.
They're the fairings.
Yeah, you can see them fall away.
Look at that. We get a little jellyfish.
Oh, wow, that's so pretty. Just a little hint of a jellyfish.
Now's the time to go outside and see if y'all can see this, folks. So now we've gotten all the way through that fairing jettison, and we have a couple minutes until we get that second engine cut off. But the track's out there. Look at this.
Oh, man. What a great view.
It really is.
Yeah, so lightning will fire for a couple minutes, but we will see SECO, which is second engine cutoff, at T plus 8 minutes and 10 seconds.
So we've got just about 4 more minutes here. Now, a lot of times we see the little ice sort of coming off. You see little pieces of ice and stuff like that. Remember, all this is chilled down, and ice does build up. I think it's little pieces of fog that it's taken with us. This looks like it's the forward-facing payload cam.
It is, I believe. That is a payload right up front, I think.
Excellent.
But yeah, all that ice gets nominally either melted on the way through the atmosphere or shaken off during flight to where that added mass isn't any hit to stage 2.
Makes good sense. It's something we see on a lot of launches.
Yeah.
Still tracking it down. I just love the colors on this shot. This really is one of the things, you draw a rocket as a kid, and you have the pencil flame coming out of the bottom, right? And once you get up there and there's no atmosphere to push that flame back into that sort of pencil rocket exhaust shape, it just goes sort of straight out the sides there.
It almost looks like one of those little comic book, kapow.
Nice.
It's kind of the shape it reminds me of.
So still have it from the ground, and we've got video from the vehicle there. Coming up on T plus 6 minutes. And 6 minutes, 10 seconds. We've got about 2 minutes left in the burn of the Lightning engine.
Man, I wish we could hear it.
I'm telling you, microphone on the structure.
Microphone on the structure.
Pick up the
it's
vibrations.
Genius.
Yeah.
You should work for Firefly. Why aren't you in the structures department, John?
I am right now. I'm working with Firefly, so.
I love the glow as well. You can see it kind of climb up that nozzle extension as it gets hotter.
Yep. And they've still got it going downrange. That's got to be one of the ground trackers out there at Vandenberg. Coming up on 7:10, 7 minutes and 10 seconds after liftoff. So about 1 minute left in the burn. Now, I don't know exactly how long we're going to have this link to the ground station with the live video, but we're going to continue showing it to you as long as we're getting it here. There's those payloads again. Well on their way to space.
Should be coming up on Seco.
Seco. Nominal orbit insertion.
I'm shaking a little bit.
There you go. Well, you heard right from the launch net, nominal orbit insertion. I do want to point out the video, we don't exactly time that video coming down, so I wouldn't look at the exact timing of the video versus the time we saw it come off. It does take a little bit of time for that video to get down from the rocket, go through the ground stations, make it all the way over to the video servers, then we get it encoded and we send it back out. So that exact timing, because, oh, look at that. That's cool. Is that the Terminator? The limb of the Earth there on the right-hand side? We had a little rotation there. What, you know something? There you go. All right, you saw it sort of freeze. No pun intended. I mean, it's not a pun. It's actually ice.
It does freeze.
The video feed freezing up there. It looks like we lost the link to the ground station, but you heard a couple different things before we got to that 36-minute coast phase. The biggest one was nominal orbit insertion call out on the launch net.
That is a good thing to hear.
All right. All right. So the important thing here is that the mission is not over. We are still coasting in this coast phase. We still have payload deployment coming up. We're going to stay live all the way through payload deployment and share as much of that with you can. Remember how the ground stations work. If we get the link back, we'll try to show it to you. If not, we might not have that visual to show you, but we will be standing by for the confirmation. And the other thing is, just because it doesn't go over the first ground station, or we don't have that first ground station, we might be able to get over the next ground station. It doesn't just pass one ground station on its trip around the planet, where Firefly Alpha Flight 5 has put it on its way. It looks like we might have acquired it again for a second here. That's just too cool.
That is so cool.
Hey, folks, a quick reminder here. Again, the feed may come in and out, but you know something? I would argue that we show you as much as we can get because I know what the Rocket Nerd's like. But if you caught this anywhere, if you've got a shot from your cell phone, it doesn't even have to be a fancy camera or anything like that. The best camera is the one you took a picture of the jellyfish with. So if you've got something, I'm going to listen for 10 seconds instead of talking about posting on social media. Really don't want to talk over anybody, but I think that might have been expected loss of signal.
Yeah, that might have been LOS.
In 10 seconds. You know when you're talking and then somebody's talking in your ear, sometimes you don't quite get it. I think that was expected LOS in 10 seconds. But if you took some of those photos, tag us over on social media. It's Firefly_space on x.com. Now we've got the payloads well on their way. More